Hello friends, in this lecture we are going to see the different terminology which is related to the projection of line, so we can solve any type of projection of line problem. This terminology very much important because the different problems related to the projection of line are given with respect to these terms, and there is a different relations between these terms are there that we are going to see in detail today. So first of all, we'll see the problem. In this problem, what is given? A line AB 60 mm long makes an angle of 45 degree and 30 degree with the VP and HP respectively. Draw the projections when end A is 15 mm in front of VP and 10 mm above HP. So we first write the analysis of this problem. So it is given line AB 60 mm long, means this is the true length of the line. So I will write here true length is equal to 60 mm. Then this line makes an angle of 45 degree and 30 degree with the VP and HP. So here we have to take care that in the regular problem, first of all the inclination of the HP is given, but in this problem it is given in the reverse direction, that is 45 degree and 30 degree with VP and HP respectively. It means inclination of the line with the VP is 45 degree, whereas the inclination of line with the HP it is 30 degree. So it means theta is equal to 30 degree here and phi is equal to 45 degree. Theta means it is the true inclination of the line with the HP, and phi means it is the true inclination of the line with the VP. And the position of the point end A is given, that is A point is 15 mm in front of VP, 15 mm in front of VP, whereas 10 mm above HP. This is the location of this point. So as usual, as in the regular problem, we firstly locate the point A first. So we draw the XY line first here. So this is the XY line. Draw the XY line first. Then after this, locate the A point. So the location of A point 15 mm in front of VP, 10 mm above HP. It means its position is 10 mm above HP, means its front view is 10 mm above XY line, and its top view is 15 mm in front of VP, means top view is 15 mm below XY line. So this is the top front view of this point, that is the A dash, and this is the top view of this point, that is the A. Then as we carried out in the last some problems, that is first of all we locate the line inclination with the one plane only, that either with respect to HP or with respect to VP, and we consider that the line is inclined to only one plane. So firstly we assume that the line is inclined to HP only and it is parallel to VP. So I will draw a short line, horizontal line here, just to plot the angle. This is the reference line. Then plot here angle theta, that is inclination with respect to HP. Inclination with respect to HP we plot in the front view. So this is 30 degree angle. Draw the line here. Then on this, as this is a true angle, on this we plot the true length of the line 60 mm. So plot the length of this line on this, that is 60 mm here. So here I'll get the point. This is not the actual front view, that's why I denote this point as a B1 dash. After that, project this point for the top view. So here in the first step we assume that the line is inclined to HP only and it is parallel to VP. So its top view will be horizontal line. So project this for the top view, and here draw its top view as a horizontal line. So this is the B1. As this is the B1 dash, it means this is the B1 point. Then after this, in the second step, we plot the inclination of the line with respect to VP, that is 45 degree. Here we assume that the line is inclined to VP only and it is parallel to HP. So we plot the inclination in the top view, that is 45 degree here. plot the 45 degree angle here, 45 degree, and mark on this 60 mm as the true length, as this is a true angle in the top view. So this angle is 30 degree, inclination of the line with the HP, and this is the phi, that is 45 degree inclination of the line with respect to VP, and here I plot the length of 60 mm. So this point is the B2 point. After that, in the second step, we assume that the line is inclined to VP and parallel to HP. So that's why its top front view will be horizontal line. So I will project this up to the horizontal of A dash. I will draw here one horizontal line which will meet with the projector of B2 dash here, and this point we denote as a B2 dash. This is the B2, this is the B2, and this is the B2 dash. After this, we are going to draw the locus line for the B2. This is the locus in the top view, locus line for top view. I denote this as the locus of B, that is the locus of top view of the B, and this is the locus of B dash, that is the locus of front view of the B. So this is we denote as a locus of B dash, that on this locus there will be the front view. Somewhere on this locus there will be the front view of the B, and on this locus there will be the top view of the B. Now if you observe, in the front view there are two lines are there. One is the A dash B1 dash, and second is the A dash B2 dash. Out of these two lines, A dash B1 dash is the true length, whereas A dash B2 dash is the apparent length. So we take the apparent length in compass, because when the line is inclined to all the planes, the apparent length will appear in the front view. So take this A dash B2 dash distance in compass and rotate this up to the locus of this B dash. So this will be the B dash point, which is our front view. So I will join this front view here. This is the front view of this line. Similarly, in the top view there are two lines are there. The first one is the AB2 and second is the AB1. Out of these two, AB1 has a apparent length, and whereas AB2 is the true length. So take AB1 distance in compass, AB1 distance in compass, and then rotate it. So we take the apparent length in the top view in the compass, that is AB1 in compass. By using compass, I rotate this up to the locus of this B. This projector goes upward, and wherever this projector intersect with this locus of B, that point is the B point. Then join this A and B. This is our top view of this line. So this A dash B dash is the front view of this line, whereas the AB is the top view of this line. If I join these two, then A B dash and B projector will match with each other. Like this. This should be matched with each other. This is must. Now we are going to see the different terminology related to this problem. In this, there are two lines are there, A dash B1 dash and A B2. These are known as the true length of this line. So I will write here, that is A dash B1 dash is equal to A B2 in the top view. So see, A dash B1 dash in the front view, whereas A B2 in the top view. These are the true lengths. True lengths in the front view and top view. Whereas in the A dash B1 dash, A dash B1 dash in the front view and A B2 in the top view, these are the true lengths in the front view and top view. And remember, in this, most important is that we are going to plot the true length on the true inclination of the line only. So this is the true inclination of the line, so we plot the true length on this. Similarly, this is the true inclination with the VP in the top view, so we plot the true length on this. Then In the front view, there is another line is there. There is a dash b1 b dash and a dash b2 dash. So the length of the a dash b2 dash and a dash b dash is same, because a dash b2 dash we take in the compass and we rotate up to here, locus of the b dash. So the length of the a dash b dash and the length of the a dash b2 dash, a dash b dash, a dash b2 dash, these lengths are same, and these are known as the apparent length in the front view. Apparent length in front view, it is also known as a front view length, FVL, and it is also known as a elevation length. So this line length is known as a front view length, elevation length, and it is apparent length in the front view. Whereas in the top view, AB2 is the true length, whereas AB and AB1, these two lengths are same, because we take the AB1 in compass and we rotate this. So length of AB1 and AB is same, and this is known as a AB is equal to AB1. This is the top view. So this is the apparent length in top view, and it is also known as a top view length, TVL, and it is also known as a plan length. So these are the terms related to the lengths. There are 2 true lengths and like this 4 apparent lengths. In the front view there are 2 are there, top view there are 2. And one more thing, see this true length, when we extend the true length from front view to top view, it is matching with the horizontal line with the A, and then we rotate to get the top view. Similarly, from the top view, if I project the true length in the front view, it will match with the horizontal line with the A dash, and then if I rotate it, it will meet with the B dash to get the front view. So like this we can use this in the reverse order also. That is, if top view is rotated first up to the horizontal of A, and then if I project it, it will meet with the true length in the front view. Similarly, from here, if I rotate the front view first of all up to the A dash horizontal, and then if I project it up to the locus of B, then there will get the true length. So this is known as a true length of this line. This is called as a FVL, the front view length. This is also FVL. Then this is the top view length, TVL. This is also top view length, TVL, and this is the true length of this line. So these are the terms related with the lengths. Now there are some angles are also there. See, this is a true angle of the line in the front view. So this 30 degree is known as a theta, whereas the inclination of this A dash B dash, this angle is known as a alpha angle. That is the apparent inclination of the line with the HP. Whereas this 45 is known as a phi. That is a true inclination of the line with the VP. Whereas this apparent inclination of the line with the VP is known as a beta. So I will write here, theta means what? It is the true inclination. It is the true inclination of the line with HP. Then phi is the true inclination of line with VP. Whereas alpha is the apparent inclination, because on the apparent inclination we plot the apparent length. So this is the apparent inclination of line with HP. So this is the alpha, apparent inclination of the line with the VP. And lastly beta, that is the apparent inclination of line with VP. So these are the terms that we need to learn, understand thoroughly, so that we can solve any kind of problem related to the projection of line. And the different problems related to the lines are given with respect to these terms. So we have to understand this. So if you have any kind of doubt, you can message me. And if you like this video, please click on the like button, subscribe to my channel, share to your friends so that they can understand these problems easily. Thank you very much.